Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Orthogonal Array in Software Testing. Our guest speaker today is Prasad Vartak, Team Lead Testing at Accenture. Prasad Vartak has 8 years of work experience in manual testing and has worked on insurance, finance, and retail projects. Prasad has done his bachelor's in electronics and telecommunication and has worked in insurance, finance, and retail domains. Prasad is currently working on Tools SME for Rational Suites used in Test Management Quality Manager, Requisite Pro, and ClearQuest. So without further delay, I introduce you all to our guest speaker, Mr. Prasad Vartak. Over to you, Mr. Vartak.
Thank you, Moini, for that. So without waiting, I believe we would just start with today's webinar series. So today's topic, I'll be presenting the orthogonal arrays in software testing. Will be, as this is more like a statistical way of testing, we'll be seeing how these orthogonal arrays can help us in software testing and how this can be very benefited in our day-to-day testing process. So here's the agenda for today's session. We'll be starting with an introduction of what is an orthogonal array and or maybe how a testing is done. We'll be getting an insight of what are the challenges, and then we'll proceed towards why orthogonal array, where we will be discussing what is an orthogonal array and why it is used and why we have decided to use this in our testing. And then we'll see a few steps of how to use this orthogonal array in software testing. And then we'll see a quick overview around the benefits and then disadvantages. And finally, we'll end up with the session with a Q&A session. So here's we'll start with the introduction section. So purpose of testing. Why do we test? We test normally to detect and resolve the errors as soon as possible. And this is what is actually expected by the end client so that we deliver him the product which is very much bug-free. We also verify whether we have met the client expectations or not. And normally what we also see is to ensure that all the operations that are present in the product are functioning or not. We also check for that during our testing. And it may also be done to train and pass the ownerships from the portfolios to the all other users as well. So our goal is to reduce the business risk associated with the use of a product by providing management and users with the appropriate quality related information. So in short, why do we test? We test in order to meet the business requirements as well as satisfy the customers and deliver him what is actually expected by us. So few challenges around testing. Testing is very intensive and it can be very costly if you are not able to or unable to estimate properly, or if you're not able to plan your testing activities, then it may be very exhaustive or it may be very time consuming and it may lead to increase of your cost in the project. And the best approach, what normally is followed across the industry, is they prefer to do an exhaustive testing, and we just emphasize resources that they should be performing the exhaustive testing and we expect them to do that within a short frame of time. And this normally it results in work-life affecting the work-life balance of a resource. And in practical scenario, an exhaustive testing is not achieved. And I really, with my experience, I don't prefer to have an exhaustive testing, but I would prefer a smart way to perform testing. Uh, and one of the challenge which I have seen personally is we normally have some trade-off between the efforts and the quality assurance. So one of the challenges to see or come to a benchmark wherein we have a good trade-off between the efforts and the quality assurance. So this is what the one of the challenges that we have. So I'll just show you a small slide. This diagram is actually shows an overview about how much testing should be done. If you see, there are two question marks in the diagram, which is on the left-hand side, it shows that the underinvestment in testing, and on the right-hand side, it shows that overinvestment. So this is with reference to the cost of the testing and quality of testing. So we need to have an benchmark or an trade-off between these two parameters. Normally, we end up going on to the higher side of the cost, or we end up going to the higher side of the quality of testing with effect in the cost, with increasing cost. So in order to have a trade-off between them, we have an approach wherein we can have a good trade-off between them. We can have the cost leverage between some considerable amount without affecting the quality of testing. So this diagram shows us an overview about with OA or means the orthogonal array. We would be able to have some appropriate amount of testing with some acceptable amount of time frame and some good quality as well. Good quality, it means the coverage of all the requirements within a minimum amount of testing. So orthogonal array is also known as an applied statistics way of testing. It is also named as an pairwise testing or combinatorial testing. So there are various ways in which orthogonal arrays are named as. It is a statistical and more like a systematic approach of testing in which we apply the statistics, and it is normally used for design of the experiments. We can also use this for any type of testing, that is for system, regression, configuration, and performance testing. So why orthogonal array? So this orthogonal array technique, it actually helps us to test the pairwise combinations of all the selected parameters. Normally during testing, it is normally observed that when you have your test data, you test your test data individually. You don't see any errors, but when you combine certain test data parameters and you test the application, you are bound to get some errors, or you get some errors once you perform the test. The reason because errors or defects, they don't occur independently. They normally occurs when they are integrated, or when a pairing is done between those data. So then only we are bound to get some errors. So in orthogonal array, it helps us in creating a concise test sets with very few test cases, then testing all the combinations of all the variables, which would consume most of your time. Normally, when we have a combination testing, at times this task is performed manually. in order to perform the pairs and then perform the test. But in this scenario, this tool, it actually helps us in forming the pairs. And when you form the pair with the help of a tool, there's a very less possibility of errors in those combinations. Whereas in manual way, we are bound to make mistakes, or we are bound to skip certain scenarios or combinations in that. It also creates a test set that has an even distribution of pairwise combinations, which are as per the system under test or application under test. So it is similar to generate and is less error prone, and test sets which can be generated manually, which requires certain accuracy. Orthogonal array, it gives the effective test cases to be executed. Sometimes it may also list the number of test cases that one may identify manually. So these are one of the reasons why we would need orthogonal arrays. So now let's jump in to see how this can be. Yeah. So here's how we would be performing the steps for using the orthogonal array. We'll decide how many independent variables will be tested for the interaction. Say at times, say as an example, if you take an example of a report, in which in order to get the report, you would need certain filters or certain parameters through which you can apply the filter and get the result required results. So in this scenario, um, you will, for designing a report, you will know which parameters are, so you'll know which parameters are normally required for testing. So in that, this will map to your factors. Factors will be the horizontal, the various columns that would have all those variables in it, and will decide the maximum number of values, the values in which these are very independent to each other, and this will map to the levels of this array. And in order to find a suitable orthogonal array with the smallest number of runs, we arrange it in a grid format, wherein it will give us an array format like this. I'll just So this is the one which I was referring to. We'll have the factors, which is the columns, the various columns in it, and we'll have the levels in it. So levels are something which will have the values in it. Say for example, for testing the reporting for a report, you have the various variables in it, and in that variables you have a filter criteria. Say the level will map to the filter value, and the factor will map to the attribute, and each combination of the factor and level will correspond to a run. So this will correspond to one test scenario or to one test conditions of yours. So once you have done that, you also choose the values of any leftover levels as well, and then what you do is you then copy all this into the form of in a sample txt file. And what we do here is we make use of a small utility which is named as all pairs. So all pairs is a very it's a free form tool, and it is used, it uses the orthogonal array approach, and we can just use it in order to get the required orthogonal array result. So once we have all the data, the Excel data transposed in an TXT file, we access the tool through a command prompt. And if you see just an example, in below the point number 7, I have just updated a sample path, that is d colon whatever your folder name, then the all pairs.txt. Then you should mention the sample.txt file and then a greater than sign, and you should update an output file name that would be in the form of a text. So once you enter this path and you click on enter, you will get a sample output which can be used further in order to perform the combinations or get the end results. So I'll show you one example in the slide, in the coming slides. But before proceeding to that, let's consider certain the key points before getting into the actual samples. You should ensure that the chosen test scenario will be tested at all the levels, and you should also identify the factors and levels that should be done by people with some system or domain knowledge, whatever your test data or what your attributes that you need to perform, you need to use to test your application. These anomalies should be identified by some person who has very much experience into their domain or very much well versed with the tool. System or domain knowledge should be coupled with OA competence, and that is the knowledge of the levels, the factors, the result analysis as well. So the person should be very knowledgeable in order to interpret the output results. Identification of a suitable test scenario is a key factor, and there are some situations where OA techniques are not applicable, such as some processes which involves factors which are variable in time. So there I don't think it would be applicable. But of course, in software testing, this would be applicable. But at times where some auto ID would be generated in the tool, some ID which gets automatically generated with reference to certain time or some point or some instance of time. So therein, we cannot use that parameter for the OA technique. It is normally applicable to a black box testing. And there's one misunderstanding with this approach is that it helps in reducing the number of test cases, but this is not always the case. It depends upon the combinations or the number of factors that you are using and the number of levels. So we'll have a brief understanding of this in the next coming slides. So I'll just take you to an example. So consider this example in which we have a 4x3 array. That is, we have some 4 factors and with 3 levels in it. So in order to test this, what we need to have, we need to perform some exhaustive test, and in order to perform this, we need to have at least 81 combinations or 81 test cases. That would be 3 into 3 into 3 into 3. So this will be 4 times 3. So you'll get around 81 combinations of your test cases. So ideally, I don't think that we would actually need this, or we would actually require this much of combinations to test it, or the time won't permit to perform all these 81 test cases. Say this example is just for a 4x3 array. Consider an example in which you have a 10x10 or something like that array, so in which the combinations would be more than 1,000 or so. So due to the time constraint, I don't think it would be possible to test up such an array. So what we do is we give this result as an input to the orthogonal array in the all pairs tool, and we get the result as below. If you see, it gives us only 10 combinations, wherein each of the parameter has a pairing of 6, wherein the last column pairing, it shows that 6 times this combination is, if you test this, 6 combinations would be tested. So this is how this OA works on. If you are able to catch hold of the OA results in the Excel sheet, you'll better understand because the pairing details are given below the Excel sheet, which I am not able to include in this slide currently. But if you can just open the output file in an Excel, you'll be able to see the combinations. So just move on. So this is as per the industry's standard within saving and optimization charts. So what we have is the levels or the parameters. So if you have, these are the number of levels. So with 2 parameters, what they say that it would be saving of around just 0. And with 3 parameters, what you have is around 50% of saving. So this is how, so as the parameter increases, so as with reference to that, these are the savings that you would be able to get. These are just the industry standards. These are, I have received it from one of the portal wherein they have updated the savings for the orthogonal array which are achieved. These are the practical new numbers by some industry analysts. So some benefits around the orthogonal array. So it helps us in reducing the cost actually by identifying the non-testable requirements and the redundant test flows early in the cycle. This helps us to plan our testing efforts and also our testing activity. It also results in maintaining the overall quality of the test application of the product because with minimum number of combinations, you are able to test exhaustively the application. This can be applied to any phase of your testing, that is your unit, integration, system, or acceptance testing. This also helps us in reducing the test cycle time of the test phase. At times, with reference to the saving slide in the previous slide, at times it may not be applicable, but of course if you have the pairings are very much greater, then it will certainly help us in reducing the cycle time. Since we are covering the entire combination of the data or of the application, it helps us in finding maximum number of defects with minimum number of test cases. And hence it helps us in increasing the coverage to maximum with minimum number of test cases. This also helps us in reducing in the productivity improvement with cycle time iteration, because as the testing progresses, the productivity of the resource also gets improved. And the next point that we saw, that is, it helps us in improving the test coverage. This can also be used in data-driven framework, wherein you might be using some automated testing for the database data-driven frameworks. So it's up to you where you would like to apply this approach for your testing and get benefited with the optimal testing of the data. Of course, any approach, it may have its benefits, but it should always have its disadvantages as well. So some disadvantages we'll be discussing here. There would be no reduction in the number of test cases wherein the number of factors are 2. We have already seen under on the saving slide actually, wherein for factors number 2 it won't give us any savings. The user should also at least have some knowledge of the system or domain wherein the factors and its corresponds level. You should always have some knowledge of prior knowledge. Without that, you will not be able to find out the levels and factors. The factors chosen must be such that it gives maximum coverage of the functionality to be tested. And the limitation of OA is that it can only be applied to the initial stage of the product, process, or design phase. And there are some situations where OA are not applicable, that is involving the factors that vary in time, and it is only applicable in black box testing. So this in white box we cannot make use of it. So we'll proceed towards the next slide. Just one suggestion from my side, that this approach is it's just a tool to be used to enhance your testing skills, and this is not a way to replace your testing skills. So this is just an suggestion from me. So now we are open for questions if you have any. Hey Mohini. Mohini, are you there?
Thanks for the insightful presentation, Mr. Vartal. Let's quickly take up the questions now. Please read out the questions and their answers so that all our users may listen to the commendable insights. Over to you, Mr. Prasad.
Yeah. So first question was from one of the user, that is not able to get his name. Uh, So the first question I'll take from Mihir Shah, that is want to know the advantages and disadvantages of orthogonal array. I believe Mihir I have already discussed the advantage, disadvantage of orthogonal arrays. I've already shown you on this slide. If you still have any queries, I can just share the PPT with you. So what is the allpairs.exe file, and what I'll do, and how do I get the file? So Nagraj, the allpairs files is, if you just Google in, you'll get the allpairs file. So it's a, I'm not, since I'm not from the development side, I'm not sure what's inside that file, but it's a file which will process the data and give us the orthogonal array results. And so we have one question from Nikita, how to set the factors for orthogonal array. So for setting up the factors, you need to identify which data or what type or which attribute you'd like to test in initially. Say, just as a simple example, you're working on a login screen. So your factors on the login screen would be your username and the password. So these would be two factors that would be working in initially. So this is how you need to identify the factors which would be under test. From Rajesh, we have one question. Is all pairs exe and open source available on the net? Yes, certainly. This is a freeware available. We also, since all pairs is not the only tool, we have various open source tools for orthogonal array or the pairwise testing approach or statistical testing approach. You can just Google in and you can catch hold of any tool. We also have one tool, Hexawise, which have some advanced feature in it, but I believe it is chargeable. You can just check it on the portal of Hexawise. But as far as I know, all pairs it's very beneficial and it's a freeware which won't add any cost to your existing budget. So Rajesh, your next question: explain factor and level used in OA technique. Any example is I just explained it in the example. So another question that we had from Rajesh. Values of OA can be different data types. Yes, certainly. The values of the OA can be of different data types. It's up to the factor. Um, uh, the factors wherein what are levels it can accept. So I believe the values that you're referring to the levels. Rohit is asking for one more example, how to apply this technique in real-time scenario. Rohit, take an example in which, say, you have a screen in which maybe a screen in which you enter the user details, and then what you do is the expected functionality is to capture the user details like your username, his age, his location, then his address, his PIN code. All these details are captured on the screen, and with that you give him a unique processing ID or some unique ID, say the UID. Take an example of an UID. So it will create an UID for that. So in that page, what you will have around 15 to 20 attributes. So these attributes will map to your factors, okay, and the values in those attributes will map to the levels. So in order to perform a test on it, you need to have a combination of all these the factors and the levels, and then you'll perform a run on it. Consider the just take an overview of the table that I've shown, that is the factors, levels, and runs. So this will actually help you to get the number of scenarios that you are trying to test your application. OA testing is done. How OA testing is done in unit testing? Uh, in normally unit testing, what you do is you pass on data from within the within your particular module and not to the integration. From in one single page, you perform certain say example in unit test. You have some rule engines which are applied on a particular page wherein to process the data that particular page has. So in that you have the combinations. Wherever you have the combinations, you can apply the OA techniques. We have one question. Is that helpful in product-based testing? Yes, certainly. uh, you can certainly make use of this technique for some product-based testing as well. Let me see another question. Why it is called an orthogonal testing? See, with reference to the name, it refers to the axis of two parameters which are very much 90 degree perpendicular to each other in one axis. So they form an orthogonal, and in which so that is one of the reason it is named as an orthogonal. You can just Google in and get more insights why it is named as an orthogonal. So what are the parameters to select the factors? See, there are no parameters to select the factors. The only prerequisites is that you need to have some good understanding of the application under test. So with that, you would be able to determine which factors you would like to test and how to test, and then you can plan your testing accordingly. We have another question, that is, can we use this in compatibility testing? I don't think we can use this in compatibility testing. The reason is compatibility is something different wherein you check how the application is compatible with various operating system. Here we cannot use it. But in order to get some combinations of the operating systems, say for um, in one operating system, you have various browsers. You would like to test the product, how it behaves in various browsers. If you would like to know that combinations, then you can certainly use it. But as a part of compatibility testing, you cannot use it. Venkat, I'm not able to get your question, which refers to how can you use mixed mode OATS. I'm still not clear. Not able to get mixed mode OATS. If you can just give me an insight about what do you mean by a mixed mode. So we have one question from Suresh. We are doing a system testing for a product. How much is it feasible to adapt this technique, as we are the third-party testers and we don't have any requirement of? See, it doesn't, it's not mandatory that, or is it not required that you mean the primary owner of your testing? See, since you're a part of a testing, you might have all the access to your test data and the application. Even though you don't have the requirements, that's fine. But if you have all the test data, you know the application end to end, and with the amount of the test data to be tested, with the help of the test data, you can give the data in the orthogonal array, that is the all pairs tool, and you can get some optimized pairing of those data in such a way that you end up results in squeezing your testing time. So Anuj has one question. Can this be used in manual as well as in automated testing? Yes, certainly it is. The scope of this testing is to black box testing, and at times it can be also used as an input to the uh, data-driven testing approach in automation. So there's one query: how can we justify the OA to your project manager? You see this tool, this approach, I this will give a end result only when you have the right amount of data with you and you have the right amount of factors and their levels in it. And you can show your seniors or to your project managers the amount of the coverage that you are getting with while using the OA approach and with the existing old approach. So by comparing all those and showing the difference in the efforts of testing, so you can just justify the OA with your project managers. How can we use OA in any automation tool? See, we have just defined the OA scope for data driven, wherein in automated testing tool, wherein we have some test data which is actually saved in an Excel spreadsheet. So wherein instead of that data, we can put in the combinations of one scenario of the data. So this is way it can be used, but it won't be driving any automation tool. So it will just act as an test data input to the automated tool. How can the OA help in web testing? See, any type of testing, whether it can be a product or web-based testing, I don't think there would be any difference in it. The only way we work on different environments on each of these testing. Um, with my personal experience, what I feel is the only differentiation factors are the attributes and its values. So you need to find out. That's what I mentioned, that you need to be well versed with your application. Then we would be able to perform, or we would be able to uh, take on the uh, parameters. What is the difference between a pairwise and orthogonal testing? See, pairwise or orthogonal testing. Pairwise is something we normally, in pairwise testing, what we do is we just pair the data values and we take those values the uh, in our testing in our system under test, and we test that particular tool. But in orthogonality, what we do is we take those pairs, and with the reference to those pairs, we take these uh, pairs and form certain scenarios in such a way that in every scenario, we'll show that how much times that particular pair is being repeated. So this is how it will show up. So let me just show you one example, and let me just unshare my screen first. I'll just show you an example. Just give me a minute and I'll just show you one end result of an OA. Just give me a minute or so. I'm just opening certain data. So I'm just giving an example of the all pairs utility. If you see, this is my data. The initial first column what I have, the first cell that is in A1. What I have is the factor. So these are the factors which I am referring to. And for each factor, we have levels. So for each level, we have some data value in it. And each row, when I say row number 2, this row number 2 will act as an run. This is my one test case or some one scenario which I'll be performing the test. So this is how this is my initial condition. This would be my first condition. Say suppose I would like to test all these combinations. So when I end up, I'll see that there are various combinations in it. So what I'll do is I'll put this data in the orthogonal array, that is the all pairs utility, and I'll run it. And when I see these are all the combinations that I'll get, I got around 35 combinations. So that's it. I believe 35 combinations. This is what it gave me. So when I see, if I would like to interpret it, see my first parameter is PPS, right? The PPS, if I see, variable is PPS in the test cases. When I move back to the test cases, it will show me PPS. Then if you see over here, there are pairing. How much pairing is it? Each pair has around 171 combinations. So when I see one PPS and PR, if I just scroll down, PPS and PR, I'll just see. This is the PPS and PR. There's one value, one and all. So in this, when I go and see that there is some 171 combinations, it says that the PPS and PR, each of the pair, it has a combination of 171. This is what it means to say. Let's take another example of some small pair. This value, 1 range, 4, I guess it's 4 and range. So I'll just see 4. So it means that it shows that 4 range and 5C. Each pair when you see, you have to just scroll down to all these pairing details to see all those. In this appearances, it will show that how many times it gets appeared. say, see this combination that PPS 2 and C, it shows that it appears twice, wherein it appears in case number 11 and 28. So if you see in 28, it's what it is, it's 1, here it is 1, and here it is 2 and C. Okay, and if you see in 11, I'll just scroll up. So in 1, and here it is 2 and C. See, this is how it shows that how many times this particularly appearance is there, and in which test case it is appearing. This is how it shows that. So this means that each of the pair is tested at least once in one particular combination. So that is why if you see in all these 35 combinations, we have all the pairs which are repeated or which are coming at least once in that particular scenario. So I'll just take on a few more questions. We have one question from Adi, that is how it is helpful for performance testing. Performance testing in which I don't think it would be applicable. Maybe it depends upon the data or the what type of data you're performing or which parameter you're performing. If it is more or like uh, the combinations of data wherein you check the performance of the system or the or the turnaround time of the system, therein for getting all those combinations you can use it. There is one more question. Is there any base for selecting the factors? No, there is no such base in selecting the factors. What we have is some prior experience that we would like to have in order to select the factors. We have one interesting question. Suppose there is an array of n is to n. So how much conditions that needs to be to derive the possible solution? Suppose you have an array of n is to n, say, then you should at least have n raised to n values multiplied by n raised to n values. So it will be the combinations of that. So say suppose for example you have 4 is to 4 array in which, so what you have is it would be around 4 into 4 into 4 into 4. This would be 4 times 4. So this is the number of conditions that you need to derive to get the required test cases. How orthogonal array testing have upper hand than the pairwise testing? See, pairwise testing, the scope would be just limited to the pairs, in which we just test the pair data. But in the orthogonal array, with the help of the pairs, we come up to certain test cases, which should be used to test the application under test, or the data, combination data, which should be used for testing the data under test. So this is the way it is well ahead with the pairwise testing. If we don't know all the possible test conditions, how will we ensure that coverage of all the conditions? So I believe if you don't know all the possible test conditions, then I think you are not aware of the application under test, and with that you won't be able to know that uh, which data that you need to test or which areas that you need to test. But you need to find out that first, then only you'll be able to know that how much data would be covered with this. What are difference fault in OA? I don't think there is any fault in OA. I'm still not clear with this. How does it help to improve the performance in decreasing the risk of failure of a test case while automating? I think this is a pretty out of the scope of the topic which you are referring to. Ankita, if you can just mail me, I'll be able to answer your query. So I think that's all I have from my side. So I'll just transfer to Mohini to just close this session.
Thanks, Mr. Vartak, for your session on orthogonal array in software testing. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on techgig.com by tomorrow. Thank you.
Okay.